which is more than the, sorry, what happened? Okay, so but for that you have to use brute force, and the process of interface fitting by driving it, there's a process I will show you. Uh, it induces a compressive resistance around the hole. That's a, it is a beneficial effect. But sometimes you have to fit it using freezing. Any idea? Any of you have come across where they use interface
Just
fitting in the
freeze
process of freezing?
plugging of the holes. Holes are freeze
Uh-huh.
plugged
Pardon me?
in some structures.
No, no.
Liquid
In what
nitrogen or
purpose and
cold
what
liquids,
material
it is
use?
frozen. Yeah.
Any idea? Correct. Yeah. Correct.
Bush
Yeah. And what
material,
bush material
I
they use?
don't recollect, but it is non-ferrous, I believe, sir.
Steel, mostly
Uh,
steel.
no, I'll tell you. So the, yeah,
Hmm.
another signing example. The people would have seen the bullock cart, right? The wheels made out of wood, but the outer rim is a steel. Okay, so though there will be a rim made out of wood, but outer ring they'll put the steel, because they will take exact dia lesser than the actual wheel dia, and they put it in the billet, they put in the fire around the steel ring. So due to the hot, it will expand, and immediately they put it in the wooden wheel and put the water, so it will cool down to the room temperature, so it contracts and holds the wheel tightly. That's why it's able to run in the rough roads and all without damaging the wheel. So another of doing interface thing is using brass. This is mainly used because any attachment points, especially main attachment point, use aluminum as the log and steel as the pin. So steel is harder than the log. So in the operational uses, it will damage the log hole. So it is difficult to remove the log and all. It's better use the bush made out of brass. So even if brass goes off, it is easy to remove the brass and put a new one. So to put in the interface port, then they put it to minus 35-degree nitrogen liquids, which will contract the brass, then put it in the hole, then at room temperature it expands. Again in the process it reduces the compressive residual stress. So if you see the comparison between the clearance speed means there is a clearance between the boost dia and fastener dia and hole dia. If certain life is the basis thing, in interface you will get almost one order. This is log scale, it will be one order. If you horizontally, one or two order life will increase due to the interference field. Again, it is preferred to use, but everywhere you cannot use, but sometimes it being used in a blind rivet or solid rivet, that is being done automatically does interference field. Or people are who are doing the structural repair as a process, SRM process, they says you remove it, put it things and all there. Okay, so this is the process how it is been done. Cold war interface fit. So you cannot, there is a video, nice video, may not be audio is possible, but it's a self-explanatory. You have to use brute force and hydraulic to push a boost of higher dial than this. So once you pull out the mandrel, it will come out, then it will be having a compressor residual stress. So you have now comparison, you have a different type, you can have a cold expansion, then interference, and different degree of interference. And you see this is the dotted line. This is corresponding to expansion plus high interference. There will be 2 degree. If you take the stress level, you will get 1 10 to the power say 4, 5, 6, 2 degree order of life you will get increase in life. So this is the procedure in the narrative way how it is, but I will explain you the video. There's an audio, it's not you will people not able to hear it, but this is the same process explained in the video. So this is the triangle joining two points. You delete there, then use a rim. No, first use rim it up. Do you know why the
Yeah.
To
people use rim?
Improve the surface finish inside the hole, right?
I'll tell you later on. Yeah, that's a boring. Boring is called boring process. So this is measuring the dia and see what is the die you have to use. This is the FTI. There's a company who makes this one process of using hydraulic thing. You put in the gun, then put these sleeves, then you put the hide sleeves, then mandrel. See, in the process mandrel you have a tensile, then it goes back to the compressor. Now usually whenever repair is there, the process is you have to remove the existing bolt, check for any crack, then usually you go for the next higher dia. So in that basis again you have to drill next higher dia. Anybody is doing any repair,
Yes,
structural repair? Yeah, so this is the why they said you have to go for next higher.